Good morning, pre-calc students. Today we're going to take a look at polynomial function of higher degrees. So we're going to get beyond just x squared. We're going to take a look at like x cubed, x to the fourth, so on and so forth. Of course, we're going to kind of take a look at how we could know what the graph is going to look like just from the equation. And we're also going to use our algebra skills to help us find the zeros of the polynomial function. So first, let's take a little warm up here. Graph the following in your graphing calculator, determine the zeros, then identify the relationship between the zeros and the number of times the factor occurs. So let me give you a minute. I'm going to pause it. Let me take a minute. You guys type those into your graphing calculators. You can put them all in your y equals screen at once, and we'll take a look at the graphs. So hopefully you're getting those typed in, of course. Make sure your calculator's in function mode. Now, obviously, I've already pulled up the graphs here to save us a little bit of time. So let's take a look at them. You can see the picture there for A. So what we're taking a look at today, of course, are the zeros of the function. So I'm looking at where it hits the x-axis. So I'm looking at these 3 points right here. So for A, I see we hit at -3, 0, and 2. Now let's take a look back at the function. So we said -3, 0, and 2. So it's like, oh, if you solve each of these factors, if I take x minus 2 and set it to 0, there's my 2. If I do the same thing with the x plus 3 and set it to 0, there's my -3, and there's my x is 0. So your solutions are also the zeros, aka the x-intercepts. They all kind of correspond together. So let's take a look at this next graph. I see we only have two x-intercepts, one at -1 and one at 2. Now, when I take a look at this, though, we really have two of these x minus 2 squared, so we really have two answers to 2. So that is going to be important on how that affects the graph. So I'm looking at C. I'm going to show you the graph here in a second. Right away, I'm thinking we're going to have 3 -3s, which really, when we look at the graph, yep, we can see it just touches your x-axis right there at -3. Okay, let's look at the graph at D. I see we're hitting at 1, 2, 3, 4, and -5. And at 1, let's go back and look at the function. So we're hitting here at -5. We should have 4 1s. Again, that seems redundant to have to write them all out. 4 1s, there we go. So what also do we notice about the graph and the zeros? Because this is going to be important when we're sketching them. So when I look at graph A, I say when these go through the x-axis like that, they cross the x-axis. When it sits here on the x-axis, we say that touches. So I can tell you right away, I see we touch on letter B, I see we touch on letter D. So let's take a look at those equations again. So letter B, letter D. So here we go. Anytime we have an even amount of answers, so I'm looking at those exponents of squared into the fourth, an even amount of answers, we will touch the x-axis. An odd amount of answers, we cross the x-axis. So that's going to help us when we have to start sketching these by hand. So, as we kind of talked about at the beginning of the video, a lot of vocabulary, it's all kind of synonymous here. X equals A is a 0. We can also call it a solution. I've seen even some textbooks refer to it as a root. You can write it in factor form or intercept form. So let's say it hits the x-axis at 7. We could say x equals 7 is a 0. X equals 7 is a solution. X minus 7 is a factor, because if you set it equal to 0 and solve, you get 7. And then, of course, intercept style, we write it ordered pair, 7, 0. All kind of means the same thing, but just depends on what they're asking you for final answers. So we kind of talked about how to know whether it touches or crosses the graph. So let's kind of clarify or get specific here with all of this. If you have an even amount of zeros, it touches the x-axis. And you can see right here, we're touching. So I know we would have x minus 3 twice. If we have an odd amount of zeros, we're going to say that it crosses. Because our goal is to be able to look at the equation and try to get some answers just from looking at it without having to do the graph on our graphing calculator. So other thing that's going to help us is what's called the leading coefficient test. So this is all based off the degree, the highest exponent, and of course your coefficient in front of that. So we're just going to sketch some graphs here, give some pictures, some generalizations here to help us too. So if you have an odd degree, x to the third, x to the fifth, so on and so forth, and a positive lead coefficient, I kind of think of it like a positive slope. We're going to have our left end falling, I'm going to draw a third degree graph, and our right end rising. So we would say the left end falls, the right rises. Now it's going to be kind of reversed. Think about a negative slope, odd degree, negative lead coefficient. So now the left end rises and the right end falls. So I'm going to say left rises, right falls. Now let's talk about if you have an even degree, an x squared. Think about a parabola, x to the fourth, x to the sixth, so on and so forth. The ends work together so that either both rise or both fall. And of course, it depends on the sign of your lead coefficient. So for our even degree, positive lead coefficient. So think about a positive lead coefficient on a parabola. Both ends will rise. Try a fourth degree, you want to get fancy. So I would just make it easy and say both ends rise. And then, of course, if you have a negative lead coefficient, it's going to flip. It's going to reflect. Both ends fall. Okay, so we want to put all of these skills together to try to help us sketch the graph without having to use our graphing calculator. So use the leading coefficient to determine the left-hand and right-hand behavior. And, of course, you can verify it on your calculator. Hopefully, we don't have to do that. So squared, I know the ends work together, so I'm just going to say both. And because you have a positive lead coefficient, they're both going to rise. If that 2 is negative, we would say they both fall. Okay, let's take a look at this guy. Super tiny. I know that's a little blurry. That 1/3 is negative there. So again, I'm looking first at the degree, odd. So they're split. They're not going to work together, so we have to write a separate left and right. Now, because it's a negative lead coefficient, I kind of think about a negative sloped line. It's the same idea. The left end is going to rise, the right end falls. And of course, if that was positive, that would be reversed. All right, let's take a look at C, our degree 4 even, so they're going to work together. So I'm just going to say both. Make my life easy. And of course, negative, they're both going to fall. Got it. So again, just using these to help us draw the graphs. That's what we're really after. Now, same thing here. We got the fraction. Don't let it scare you. I'm still zeroed in on that highest exponent, the degree 7, odd, so they're going to be split. So let me write left and right. And again, over 4, don't let that intimidate you. We all have a fraction here. My lead coefficient would be 3/4. Or really what's important about it, positive 3/4. So I'm thinking about like a positive slope. The left would fall, the right would rise. And then our last one, E, we could get fancy and distribute negative 7/8 through. I'm not sure it's really worth our time or effort. I'm looking at that highest exponent, 3. So again, we're going to be split on the ends. Those odd degrees, always opposite, one of each, one fall, one rise. And of course, if we distribute it, our lead coefficient would be negative. So think about a negative slope. It starts out high on the left side and falls on the right. Got it. Okay. So other skills we're going to use to help us get these graphs sketched by hand are finding the zeros of the function. We're going to talk about the multiplicity here in a second. So zeros, I'm going to set the equation to 0. Now, x squared minus 25. 2 answers, second degree. Easiest thing to do, and plus I like to review factoring, difference of perfect squares. So of course my 2 answers, -5 and 5. Now, determine the multiplicity of each 0. So of course, if you have repeated answers, like with that one example at the beginning of the warm-ups where we had the graph, let's click back to it here really quickly, where I had letter D here, the 4 1s. We just want to write out all of our answers so we know if we have an even amount or odd for when we start sketching. Second degree, I've got my 2 answers. I'm ready for the next one. Now, same thing, I'm going to set it equal here to 0. Squared, quadratic. So again, I would try to factor on it. So I'm thinking about what 2 numbers multiply to -2 and add it to our middle coefficient of 1. 2 and -1 work for that. Of course, if I couldn't factor it, then I'm going to think about quadratic formula, completing the square, something fun. I should have 2 answers, and I'm going to. We have -2, +1. Got it. Let's take a look at C. All right, third degree, kicking it up. So of course, I'm going to set it to 0. Pick T for a variable, always looks like a plus. Okay, first things first, I always try to factor, one of our favorite F words in math. I'm going to look for that GCF. I see every term has a T in it, so I'm going to factor a T out. So let's start there. And I'm looking at this trinomial inside the parentheses. I think we can factor that again. There are two numbers that multiply to 4 and add to -4. -2, -2. Okay, we're going to write all three answers. Our first one, of course, would just be 0. Second answer, 2. Third one, 2. Now, I do want to write all the answers. The multiplicity is important, especially for tomorrow when we start drawing the graph, just to kind of reference it. Because we have this even amount of answers, I know it would touch my x-axis there versus crossing through. It'll cross at 0. Again, we're going to use all of this good stuff tomorrow. Okay, let's take a look at letter D here. So again, same thing, squared, let's set it to 0. Now, same thing, I see 5, 10, 5, not huge numbers. Let's work smart here, it's always easier to work on smaller numbers. I'm just going to divide everything by 5. Now I'm trying to factor on it. Are there two numbers that multiply to -1 and add to -2? No dice. So you're going to either have to use quadratic formula or completing the square. I'm going to complete the square just to review that process. So let's add one over and get it out of the way. We want to recalculate this new third term so we can force it to factor. So remember, to complete the square, you're going to do half of this middle coefficient, 2, half of 2, 1, and then I square that, 1 squared. Now, of course, I have to balance and put that same value on the other side. Okay, the purpose of the green one is we now will be able to factor the right-hand side. There are two numbers that multiply to 1 and add to -2, -1, -1. And I'm just going to combine 1 and 1 on the left side. Now, it's super easy. We're going to get rid of the squaring with the square root. I'm going to move up here. Of course, two answers, so plus or minus in front of that square root. And last but not least, we're going to add 1 over. So 1 plus or minus square root of 2. Square root of 2 is prime, so I don't have to worry about simplifying it, but I'm going to think about it. I do have two answers, 1 plus the square root of 2 and 1 minus the square root of 2. Oh, those good algebra skills. You never get rid of them. Ooh, 4 answers for this guy. Okay, all right, we can do it. Now, again, I see we've got a lot of divisibility by 5 here. So first things first, I would probably divide everything by 5. Do you have to? No, but it's just always easier, I think, to work with smaller numbers. Now, don't let the fact it's a fourth degree scare you. I think we can factor on it. I'm thinking about what two numbers multiply to 2 and add to 3. 2 and 1. So I can fill that in my factors. We're just going to get fancy, though. Instead of me putting x and x, because that would only distribute or FOIL or multiply out to x squared, we're going to put these x squareds. Because x squared will give you that x to the 4th. Okay, so let's take a look. I'm like, ooh, okay. So if I set each of these factors now to 0 and I try to solve them, because we're trying to get all 4 answers as our ultimate goal. So of course I'm going to subtract 2 over on this guy. I'm going to subtract 1 on this one. And we know to get rid of squaring, an easy way to do it, square root it. But we do have a little problem here. We can't square root a negative value. That puts you into the imaginary unit system. So that means we have no real solutions for this one. So how would that affect the graph? That just means if I were to actually type that in my graphing calculator, it's not going to touch the x-axis, which is okay. Not everything has to touch the x-axis. So we're going to combine the graphs with the zeros and the leading coefficient test, all the things together. We're going to combine them tomorrow. So hopefully enjoy your homework. Have a great rest of your day.